Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Mora by Groctillion, and here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9, where without repeats in any row, column, or box. We also have digits in cages may not repeat and sum to the clue if given. So that's typical killer cage Sudoku. And therefore you would have these two digits add up to 6, these two digits add up to 9, these two digits add up to 12, etc., etc. As an example, if this were, say, a 3, this would have to be a 9 to make sure that these two digits add up to 12. And you can't have repeats within cage, but you couldn't anyways, because all these cages are just they're restricted by normal Sudoku rules too. And additionally, digits may not repeat across cages of equal sums. So if that means, oh, that's interesting. That means in all the 9 cages, you cannot have repeats. Well, that's actually very interesting for what that restriction implies. Right, so if you had a 1 here, you could not have a 1 in any of the other cages that add up to 9. So you would not have a 1 here, you would not have a 1 here, you would not have a 1 here. That's an interesting restriction. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. So, that last restriction is very interesting. My guess is... Okay, so because digits cannot repeat across cages of equal sums, we know there are 8 cells that contain digits that add up to 9, but there cannot be repeats in there. So therefore, since there are 8 cells with those digits, all 8 of those cells must be already taken. So there cannot be another cage that adds up to 9 then. That's what we know from that. And I think we have a similar case with 11s, right? There are 8 digits that can be in a cage, two cell cage that adds up to 11. 2, 9, 3, 8, 4, 7, and 5, 6. It's similar with 9, which we have 1, 8, 2, 7, 3, 6, and 4, 5. And we have 4 cages that add up to 11, all 2 cells. So that's 8 cells which do not have repeats, remember, which must 8 cells which must contain 8 digits from 2 to 9. So 11 cannot be in any other cage. Cannot be the sum of any other cage, I should say. What about 10s? We only have 3 cages full of add up to 10, and so there could be another 10 cage somewhere. So we have, and then we have 3 cages of 2 cells each that add up to 8. Well, the only possible cells that could add up to 8 are 1, 7, 2, 6, and 3, 5. That's 6 digits. So we have 6 cells for 6 digits, so there cannot be another cage that adds up to 8 either. So there's no cage adding up to 8, no other cage adding up to 9, no other cage adding up to 11 now. We have only 1 7 cage, we have only 1 12 cage, we have only 1 6 cage. I'm not sure if this is actually that useful, so let's just add up the cages here. I was just curious about that, about how that was working. So we cannot have, this cannot be 8, 9, or 11. Those are not allowed for any of the other 2 cell cages. These add up to what? This is 11 plus 10 plus 9, which is 30, plus 8, which is 38. 45 minus 38 is 7, so this is 7. What about these? We have the same exact set. This is 8, 9, 10, 11, which add up to 38, so this must be 7 again. These digits then, this can never be 1 or 7. So this has to be 2, 6, or 3, 5 here for this 8 cage. Well, this can never be 1 or 7, so this is 2, 6, or 3, 5. Well, we have a 2, 6, 3, 5 quadruplet in the 8 cages. Or the cells, basically the cages adding up to 8. I should put it that way. So therefore, there cannot be 2, 3, 5, and 6 in the last 8 cage because we know there's 3 of them. So this has to be 7 and 1. And this can't be 7 because of this 7. So this is 7. This is 1. This 1 and 7 eliminates 1 and 8 and 2 and 7 here for this 9 cage. It cannot be 3, 6 because if it's 3, 6, that eliminates both possibilities for this 8 cage. So this must be 4 and 5. This 4, 5 eliminates 3 and 5 as a possibility for this 8 cage. So it's 2 and 6. Where is the 1? In this box, and 1 has to be here because it can't be in the 11 cage. So this is 1, which makes that a 9. This then has to be 3 and 8. This 2, 6 pair eliminates 2 and 6 in the other cage that adds up to 8. So this can't be 2 or 6. It's 3 or 5. This cage adding up to 9 cannot be 2, 7 because of the 7s in the same box, cannot be 3, 6 because of the 3, 5 pair in the same box, and can't be 4, 5 because of the 4, 5 pair in the same box. So it must be 1 and 8. This 1 and 8 eliminates 1 and 8 from the rest of the box. So this can't be 1 and 9 or 2 and 8. It can't be 3 or 7. This must be 4 and 6, and therefore this must be 2 and 9. Okay. This 1 and 9, actually this 2 and 6 pair eliminates 2 from the rest of the column. So this can't be 2 and 4. It must be 1 and 5 here. And specifically, this can't be 5 because of the 3, 5 pair in the same row. So this must be a 1, which makes this a 5. This cage adding up to 9 cannot be 1 and 8 because of this 1, 8 pair. Cannot be 4 and 5. So no 1, 8, 1, 0, 4, 5, and cannot be 3, 6 because of the 3, 5 pair in the same row. So this must be 2 and 7. And this can't be 7 here because of this 7. So this is 2, this is 7. This can't be 2. That makes this 9, which makes that a 2. So the last 9 cage cannot contain 2, 7, 1, 8, or 4, 5. It must be 3 and 6. And this can't be 6 because of the 2, 6 pair in the same column. So this is 3, this is 6. This 11 pair, or sorry, this pair of cells adding up to 11 cannot be 2, 9, cannot be 3, 8, because we already have those, and there are no repeats in any of those cages. And you can't have 4, 7. This has to be 5 and 6 here, which eliminates 5 and 6 in the same column. So this can't be 6. This is 4. This is 6. This 10 cage here, or cage adding up to 10. I need to figure out a better way of putting this. I don't know. It cannot be 1, 9 because we already have a 1, 9 in a 10 cage. Cannot be 3, 7 or 4, 6 because of the 3 and 6 in the same row. So it must be 2 and 8. This cannot be 8 because of the 1, 8 pair in the same column. So this must be 2. This must be 8. This 2 eliminates 2, 5. And also 1, 6 is eliminated by the 1 in the same box as this cage that adds up to 7. So this has to be 3 and 4. and this can't be 4 because of a 4-5 pair in the same row, so this must be a 3, which makes this a 4. This 3 eliminates this 3, which makes that a 5, which makes that a 3. This cage adding up to 12 cannot be 3 and 9 because of the 9 in the same column. Cannot be 5, 7. It has to be 4 and 8. This can't be 4 because of this 4, so this must be 8, which makes that a 4. This 8 makes this a 3, which makes that an 8. This 8 makes that a 1, which makes that an 8. This 5 means this can't be 5, so this is 4, which makes that a 5. The remaining digits in column 7 are 7, 8, and 9. This can't be 7 or 8 because of 7, 8 in the box, so this must be 9, which makes this 7 or 8. 8 can no longer be in an 11 cage because we have a 3, 8 already. So this must be 7 and 4, which makes this an 8. What are the remaining digits in row 1? They have to be 4, 6, and 8. This can't be 4 or 6 because of that 4 and 6, so this must be 8. That makes both of these 4 or 6. How about in column 1? We have 1, 3, and 8. This can't be 3 or 8 because of the 3 and 8 in the same row. So therefore this is 1. This can't be 1 or 8 because of that 1 in that 8. So this must be 3, and therefore this is an 8. How about row 9? We have 2, 6, and 8. Well, this can't be 6 or 8 because of the 6 and 8 in the same column. So that makes that 2. This can't be 2 or 8 because of that 2 and that 8. So that makes that 6, which makes that an 8. This 6 means this can't be 6, so that's 4, which makes that a 6. What 3 remaining digits do we have in column 9? We have 2, 5, and 6. Well, this can't be 2 or 6 because of the 2 or 6 in the same row, so this is 5. That makes this a 2, 6 pair here. The remaining digits in this box are 3 and 6, and this can't be 6 because of this 6, so this must be a 3, which makes that a 6. What are the remaining digits in row 6? They can be 4, 7, and 9. Well, this can't be 7, and this can't be 7. Where is the 7? This can't be 7 because of that 7. This can't be 7 because of that 7. Where is the 7 in row 6? It has to be here. So this is 7. This is 4 or 9, and this is 4 or 9. What about the remaining digits in column 3? We have 6, 7, and 9. This can't be 6 or 7 because of the 5, 6 pair in the box and the 7 in the box. So this must be 9. And this has to be 6 or 7, but this can't be 7 because of that 7. So this is 6, which makes that 7. This 6 eliminates that 6, so that's a 2, which makes that a 6. Okay. What are the remaining digits in row 4? We have 1, 3, 5, and 9. This can't be 1 or 3, so this is 5 or 9. This can't be 3 or 5, so this is 1 or 9, and these remaining digits are 1, 3, 5, and 9. Well, 3 cannot, well, it could be with 9, actually. 6 could be with 1. Cannot be with 3, because if you have 6 and 3 added together, that adds up to 9. And we already have all the 9s, as we said. Also, we have 8 8s, so now we know where the last 8 has to be. It has to be here. So this is 8, which makes that a 2. The 6, again, cannot be with a 3 here, because that adds up to 9, and we already have 4 cages of 9s. We have the 2, 7, 1, 8, 3, 6, which is therefore that can't be 3 and 6 there, and 4 and 5. So where's the 3 in row 4? It has to be here. So this is 3 also. The 2 cannot be with 9 because we already have a 2, 9 adding up to 11 here. And if this were 2 and 9, it would also add up to 11. So therefore, this is a 4, which makes this a 9, which makes this a 1. This can't be 1. So this is 6 and 5 or 6 and 9. It cannot be 6 and 5 because we already have an 11 cage adding up with a 5 and a 6. So this must be 6 and 9, which makes this a 5, which makes that a 9. This again is a 3. It could be with 1, 2, or 5. But it cannot be with 1 because we already have a cage which adds up with 3 and 1, adding up to 4, and therefore this would be duplicate. We already have a 3, 5 adding up to 8, so this must be 3 and 2 here. We now have 8 2s, so no, we know where the last 2 has to be. It has to be here. What about the 1s? The 1s are still kind of up in the air. 3s, this can't be 2 because of this 2. That makes this a 6, which makes that a 2. Actually, we didn't have 8 2s, but essentially we did, because this 6 means this can't be 6, so this is 5, which makes that a 6. Okay. We have all 9 6s now. We have a certain amount of 5s. We have all 8 8s. Okay, let's just go through each row then. Well, actually, this has to be a 4. This is 1 or 5. This is 1 or 5. The remaining digits in row 2 are 1, 3, and 9. So this is 1 or 3, this is 1 or 9, and this is 1, 3, or 9. The remaining digits in row 3 are 5 and 7. This can't be 7 because of this 7, so this becomes a 5, which makes that a 7. Remaining digits in row 7 are 1, 4, and 7. Neither of these could be 7, so this must be the 7. This can't be 4, so this must be 1, which makes that a 4. This one eliminates 1 from that cell, so this is a 5, which makes that a 1, not a 3. That makes that a 3. This can't be 1 or 3, so this is 9, which makes that a 1. That leaves the remaining digit as a 9 in column 5, as a 5 in column 4, and as a 3 in column 6. That's how you solve it. So yeah, I guess I didn't need to go down the first, try to use the last rule explicitly. That was really only a differentiator. Well, not completely. It was useful in eliminating possibilities in these killer cages adding up to 8 and adding up to 9. So that was helpful too. Actually, the 11 also. So that was useful, but just basically trying to figure out the first digit in the upper left box and the lower right box was probably more important. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.